Example 2 is a problem where we're going to use interest compounded quarterly. So here we've got $5,000 is invested at 6% annual interest compounded quarterly. And that means we're going to be using this formula, A equals P times 1 plus R over N to the NT. And we want to know when the investment is going to be worth $12,000. So here we have that P, which is the initial amount invested, is $5,000. That's given here. The annual interest rate, R, is equal to 0.06. It's compounded quarterly. That means that N is equal to 4. And we want to know when the investment is worth 12,000. That means A is equal to 12,000. And we're trying to solve for T. I'm going to substitute these values into our equation. So we're going to have 12,000 is equal to 5,000 times 1 plus R, which is 0.06 over 4 to the 4t. And now we're going to start isolating the exponential. So I'm going to divide both sides of the equation by 5,000. So 12,000 over 5,000, I can write that as 12 fifths is equal to 1 plus 0.06 over 4 to the 4t. I can simplify if I wanted to 1 plus 0.06 divided by 4. If I enter that in my calculator, or if you just think about it, you can see this is 1.015 to the 4t. And now we need to undo this exponential. I'm going to just simply write this one in logarithmic form. So I can take the base of the exponential and rewrite that as the base of the log. So this is going to become log base 1.015 of 12 fifths is equal to 4t to undo that exponential. And finally, to isolate t, I need to divide both sides of the equation by 4. So that means that t is equal to log base 1.015 of 12 over 5 divided by 4. And if you enter that into your calculator, you'll find that t is about 14.7 years. We were asked to round to 1 decimal place. So that's how long it'll take for $5,000 to grow to $12,000 under these conditions. Example 3 you can think of as writing your own model, or you could also sort of think of it as a compound interest. I'll write it as our own model. So we have f of x is equal to a times b to the x. And we're told that the new boat costs $32,000. That's our initial value. So a is equal to 32,000. And we know that the new boat today, which is 8 years later, so we would have the point 38,500, because after 8 years, this boat is worth $38,500, and we want to know the annual rate of inflation. So here we can write that f of x is going to be equal to 32,000 times b to the x, and then I can substitute in the values from the point 38,500, so we'd have 38,500 equals 32,000 times b to the 8th. First thing I'd like to do here when solving this is I would divide both sides of the equation by 32,000. So that I have 38,500 over 32,000. I can rewrite that as 385 over 320, canceling out two of these zeros, is equal to b to the 8th. And now to isolate b here, I don't need a log because I'm not trying to get something out of the exponent. I want to find out the base, so I can take the 8th root of both sides of the equation, or raise both sides to the 1/8 power, whichever way you like to think about it. And that will tell us that b is equal to 1.02338845, etc. Because this is exponential growth, we know that b is equal to 1 plus r. So 1.0238338 ... is equal to 1 plus r, and subtracting 1 from both sides, we find that r is equal to 0.02338, or r is equal to 2.338%. We can also solve this problem by thinking of it as compound interest. So I'll do that over here on the side. So if I do that, I can think of this as A is equal to P times 1 plus R to the T. And here, A is the same thing as above. A is the amount of money we end up with, or the price of the boat after 8 years, I should say. So 38,500 is equal to the initial price of the boat, 32,000 times 1 plus R to the 8th. And then we can solve this problem in a similar way. So divide both sides by 32,000. And we'll come up to the same thing that we had before, except at the end, we're going to get... so I'll just continue here. We got 385 over 320 equals 1 plus R to the 8th. And if I take the 8th root of both sides, I'm going to get that. I'll use this approximation. So 1.02333845 is equal to 1 plus R. And then I can subtract R from both sides directly. I don't have to substitute back in for what B is. So R is equal to 0.02338, etc.